Okay, let's continue here. There's a very important concept regarding probability distribution of a random variable x. That is the expected value of random variable x. Random variable x normally represents the whole population, and the expected value of x, the notation for that is e of x. Expected value of x measures the center of the population. In previous sections, we have learned the measurement of centers for a sample and a population, right? Do you guys remember mu and x bar? Mu is the population mean, x bar is the sample mean. And E of x here describes the center of a random variable x. If the random variable x represents the population, then E of x is the mu, the population mean. How do we find the expected value if we have the how do we find the expected value of random variable x if we have the probability distribution table for x? Yeah, let me show you how to find the value. Very straightforward. This is how, okay? Once you have the probability distribution table, this is how do you find the expected value of x. You look at the first row. You use the value of x multiplied by the corresponding probability. And then you plus the second value of x multiplied by the corresponding probability. And then you plus the third value for x and multiply by the corresponding probability. 0 times 0.25, 0 times 0.25 is 0. 1 times 0.5 is 0.5. 2 times 0.25 is 0.5. You end up with 1. Am I clear about that? How do we find the expected value for a random variable? By using the probability distribution table. You multiply the two entries in each row. You would have products, right? 0 times 0.25 is the first product. 1 times 0.5 is the second product. 2 times 0.25 is the third product. And then you take the sum of them. You would have the expected value for the random variable x. Okay? Yeah, probability histogram. Do you guys remember frequency histogram? Frequency histogram simply just convert the table to a histogram. Here is the same thing. Probability histogram, you convert the table to a graph, histogram. Those bars attach each other. And you can see in the center of those bars, you have 0, 1, 2. Those are the values for random variable x. And the height of the bar is the probability of the random variable assume each value. The probability of x assume 0 is 0.25. X assume 1 has a probability 0.5. X assume 2 has a probability 0.25. So it's just a histogram. Benefit is you are able to see the shape of the distribution better compared with the table. Okay, so let's look at the package. Number 1, what are the most basic possible results of observations or experiments? What do you think? We define an outcome as the most basic possible result of an experiment, right? So we should choose B is a definition. Number 2, given P of E equals 0, what must be true about the event E? The probability of the event is 0. That means it's not possible to occur, right? Not possible to occur means impossible. We should choose A. Number 3, The cafeteria is offering 5 salads, 4 entries, 6 sides, and 3 desserts. How many different meals could you choose that include a salad, and an entry, a side, and a dessert? You are making a meal plan. Maybe I shouldn't use. Maybe it's not right to use the word here. You are going to you are going to create a meal for yourself, right? Then you need to make your decision. Your decision has 4 parts. Part 1, determine what salad you want. Part 2, determine what kind of entry you want. Part 3, what kind of side do you want? Part 4, what kind of dessert do you want? Do you guys remember the fundamental counting principle? So this task has 4 parts. Your task here is to decide what you eat for the dinner, right? It has 4 parts. Part 1, when you choose a salad, how many options do you have? You have 5 options. Part 2, choose an entry. How many options do you have? 4. Part 3, how many options for deciding on a side? 6. How many options for choosing a dessert? 3. Are you going to add them up, or are you going to multiply them together? You are multiplying them. You are multiplying them together, okay? You are taking the product of them. This number 3 is an application of fundamental counting principle. Part 1, 5 options. Part 2, 4 options. Part 3, 6 options. Part 4, 3 options. You multiply them all. What is the result? 360? Because this is 20. That is 18. Double of 18 is 36. 36 is 0. 360. That is a fundamental counting principle problem. You have 360 options for completing your task. Number 4, which method of determining probabilities is essentially the empirical method, except that it uses computer simulations? It is D. We don't really talk about Monte Carlo, but it is an important method in probability. You can figure this out if you are interested by Wikipedia, or we don't really this is not very important in this course though. So number 5, Roger conducted a survey in his math class and found that 15% of the students are international students. He concludes that the probability of a student in his math class being an international student is 0.15. 0.15 is also equal to 15%, right? Which method did Roger use? Theoretical, empirical, subjective, or Monte Carlo? I don't think he is using computer, so this is out. What do you think? It is empirical. Yes? Yes, because 15%, that is a sample proportion. Remember, in empirical probability model, we use a sample proportion to estimate the actual probability. The sample is the students in Roger's class, in his survey. Okay, it's just a sample. It's just an approximation. The probability of a student in his math class. Yeah, this is a relative frequency approximation probability, or empirical. It is not a classical. It is not a theoretical, because the student is international. Student is not international. The two outcomes are not equally likely, obviously, right? so it's not a theoretical. It's not a guess, so it's not a subjective. The only option is empirical. Number 6, there are 4 red marbles, 5 yellow marbles, 3 blue marbles in a bag. Determine the probability of drawing a red one from the bag. This is classical or theoretical. What's the sample space here? Sample space here is 4 red marbles, right? Red 1, red 2, red 3, red 4. 5 yellow, so yellow 1, 2, 3, 4, 5. 3 blue, B1, B2, B3. How many together? How many marbles in the bag? 4 plus 5 plus 3? Is that 12? So you have 12 marbles in the bag. The experiment is you randomly draw a marble. You randomly pick a marble. They are of the same size. You randomly choose a marble from the bag. You randomly choose 1 marble from the 12. You don't see the color, right? So because those 12 marbles are the same size, they have the same chance to be chosen. Do you agree that? This is a theoretical This is a theoretical probability model. The sample space include all the 12 marbles. They are equally likely to be chosen, so it is theoretical. And we are using the theoretical probability definition K over N. The denominator is 12. That's the total number of outcomes in the sample space. Numerator K is going to be the outcomes in the sample space which favor the result. The result is getting what? A red marble, right? How many of them favor red marble? 4 of them. So it's going to be 4 over 12, which is 1 over 3. That is B. Is that clear? It is a classical model or theoretical model, okay? Number 7, determine the probability of drawing an ace from a standard deck of cards. A standard deck of cards has 52 cards. A quarter of them, like 13 of them, are diamond. It looks like this. A quarter, another 13 are hearts. Another 13, there are 13. What is this? Spades. And another 13 clubs. Am I right about the terminologies? Yeah, so 13 days, 13 days, 13 days, 13 days. And the 13 diamonds, we have ace, 2, 3, 4, 5, all the way to 10, and also J, Q, K, right? So from number 1 all the way to 13, diamond. Same with this one. From number 1 all the way to 13, this one. And 1 to 13, this, 1 to 13 here. So that is 52 standard deck of cards. We are going to determine the probability of drawing a card from the standard deck of cards, and the card is an ace. It is classical. The sample space contains 52 cards. 52 cards are equally likely to be chosen by you because they look the same, right? So the denominator is 52. We're applying the theoretical probability definition, the formula here. Numerator, among the 52 cards, how many of them favor the result getting an ace? Do you guys remember I mentioned we know that there's ace, which is diamond. There's ace, heart ace, right? There's a spade ace and a club ace. So 4 aces. So the numerator is going to be 4. 4 over 52 or 2 over 26. If you convert it to decimal, what do you have? Use your calculator. I think it's gonna be 0.077. Let me get my calculator. 4 divided by 52. Yeah, 0.0769. We rounded it up, we have a 0.077. About 8% or 7.7% chance to get an ace. Number 8. What number correctly completes the following probability distribution? So we are given that the table is a probability distribution for a random variable x. We need to fill in the blank here. We need to know it's right here. This number. The probability that getting 3 girls is 0.1. Probability for getting 2 girls, 0.3. Probability getting 1 girl, 0.4. Then what's the probability of getting 0 girls? It must be a number such that the 4 probabilities in the second column add up to 1. So we can set up an equation. 0.1 plus 0.3 plus 0.4 plus x. That's the number we are looking for. Equals 1. 0.1, 0.3, 0.4 add up to 0.8 plus x equals 1. Then x equals 1 minus 0.8. X is 0.2. So that's how do we know the value. In this problem, we applied a requirement for probability distribution. The probabilities in the second column must add up to 1. That's how do we get the value which is missing. Number 9. Find the probability of not rolling a sum of 9 with a pair of dice. Not. The keyword here is very important. You're going to pay attention for the keyword. We see a negation, right? What if we consider finding the probability of its complete? I mean, how about we consider finding the probability of rolling sum of 9? Yeah, let's see how do we find that value. The probability of rolling a sum of 9. What's the experiment here? Throw a pair of dice. That is a classical. You can find that in the second part of this section. The number of outcomes in the sample space is 36. Do you guys remember the table? Do I need to spend time to go back? This table, okay? This one. Rolling 2 dice. Those are 36 outcomes. Make the sample space. And we need to find the probability of getting a sum number 9. Getting a sum number 9. That would be here. 63, 54, 45, 36. So we have 4 outcomes favor the result of getting a number 9. So the numerator is going to be 4. Denominator is 36. So that is 4 over 36 or 1 over 9, right? Be very careful, we are not done yet. Reduce the number, we have 1 over 9. We are looking for the probability of not rolling a sum of 9. So if P of A is 1 over 9, then what is P of A bar? Isn't that 8 over 9? Because the two values, the two probabilities must add up to 1. So we choose 8 over 9. Be very careful what's your goal here. Number 10, the probability that the junior class will win Spirit Week is 0.2. What are the odds that the junior class wins? So here the odds means odds favor winning. By the definition, the odds favor winning or for winning, that means the same thing, right? Is the quotient of probability of winning and the probability of not winning. Where given the probability of winning is 0.2, then the probability of not winning must be 0.8, because the two probabilities must add up to 1. Again, we use that formula, P of A plus P of A bar equals 1, right? So you would have 0.2 on the top, 0.8 on the bottom. That is 1 over 4 by doing the math. We should choose 1 to 4. The odds favor winning is 1 to 4. So that is everything about the 7A. We have how many parts? 5 parts for this section. I'll see you in next section. Thank you for watching.